Well, I have recently broken the 1000 subscriber barrier. So, a big thank you for everybody who has been subscribing and watching my rambling videos. I intend to keep this channel as it is, the style and etc. But as everybody knows, things tend to evolve and develop. So I make small changes here and there and try to be very sensitive with what you think about things. I appreciate comments. I appreciate if you give me some feedback. Most importantly, negative feedback. That's actually a very good thing to have. Positive, okay, it's nice to read, but it doesn't give that much to the actual development. Negative feedback is really nice, actually. Don't push the thumb down button. Give the feedback. That's if you push the don't like the video, I don't know what is wrong. But if you tell me what is wrong, then yeah, thank you. That's always a good thing. And I really listen and read everything and answer to the comments if there is something to answer to. So, yeah, once again, polar bear? No. A moose-sized thanks to everybody who has subscribed and who has been commenting these videos. Well, now let's go on with the show. Hello! In this episode of eccentric machining, we are going to do something for my wife. This is for her crafting things. Well, let me explain earlier today. We now can get it through the static. Let's see. Okay.
My wife does some crafting.
Okay. Let me explain to you.
From paper. And yeah, this is actually...
of course.
Well, it's a press pedestal. And then we have the tea. Well. Oh yeah, there you have it.
Well.
There is your culprit. We have missing teeth. There. Well, I probably could make...
Yeah.
Oh yeah, we have more than one.
That's it. Okay, so, I really hate computer screens, and and I don't want to torture you how it goes. And I have done plans using FreeCAD. Well, I didn't like it, but I have noticed that it's better to have good paper plans than have no plans at all. So therefore, I will now present you here the plans, and let's see now how it turns out. Let's start. Okay. Let's take this away. Let's put her aside here. Our prominent spectator. So, now. So, this thing is actually the upper roller of this thing. Well, as you can see, it's rotating this way. I'm just trying to present them like here. So, this is the rotating thing. It's like a manual. So, you have two rotating things on top of each other, like this, and now the upper one is drilled through, and there will be some bearings, etc. And then we have the lower bearing, which doesn't have a hole through. It's as you see how it is. So, and these are made out of, let me fetch the material. Yeah, here is the material. This is 42 millimeter chrome moly. It's used for the upper and lower rollers, and some of that is also used in the it's also used in some of the other parts when some strength is required. And then all this will be there will be bronze bearings, and yeah, let me fetch that material now. It's here. It's a tube like that, and well, it will be rotating. It will be bearing these rollers up and down. You could have used like ball bearings or needle roller bearings there, but since the forces are quite high here, they might not be the best solution, because you have to a little bit overkill them. And now, as you can see, she came back. Okay, let's put her aside. Okay, and now, yeah, okay, so these bearings are like used there. And then the original design didn't have any adjustment between those. And there was a very good reason for that. It was a gearing issue, like how they could arrange the gears there. And now I'm going to neglect that one. So the upper roller is not driven at all. It's just idling there. So I will be using eccentrics like those. And those are used when you rotate them, the upper roller will go up and down. Very, very simple. And then, of course, to drive those with your hand, you will be needing the handle and the ball. Okay, that's a quite simple thing, really. Nothing special about that. So, well, in order to have everything like together, you need a frame. And this frame is then made out of, partly it's made out of carbon steel, and partly out of, what is this, mild steel, hot rolled mild steel. Let me show you the materials again. Well, here they are. This is the carbon steel. It's like that. It's 40 times 56 millimeters, I believe, 30 times 56, and this is 12 times 60. This is hot rolled mild steel, and this is it's already cut to precision dimensions, but I need to mill it furthermore. Okay, these are the materials. Where was I? Again, no. When did she come back? Okay, let's put her aside here. So Okay, now we have the frame around the whole thing, as you can see. And then we need to drive the lower roller. And this is done by a gear. There will be a 40 teeth gear caved in. The first picture here is showing the key, and then we have the gear, which is then keyed into the shaft. Nothing very special about that. Of course, we need to reduce so that you can roll it. You could roll it directly using, but that would be quite demanding to do. So we have here this gear, and then we have a pinion, like that. It's made out of chromoly, and so is this bigger gear as well. I have the material there, but it's so heavy I don't want to show it to you. It's heavy lifting. So, well, we have this pinion shaft. It's made out of cold rolled steel once again, and it will be glued into the frame, like that. It's nothing special. And then we have here a bronze bearing, which is then shrink fit to this pinion, and then we have the pinion. Well, yeah, okay. Trying to explain you things that are quite, well, how would I say, they are quite obvious. And then we also have into this pinion, we have shrink fit this 40 teeth gear. Okay. And then when this thing with big gear, a small pinion, and the bearing inside, this is everything it's one piece. And then we have here, it's placed like that, and then we have there this holding gap. Well, it's to avoid this thing from dropping out from there. It's just washer. Okay. And then we have, well, now that we have the big gear there is already some reduction of rolling it. Then we have this, we need to have a handle, a wheel, some sort of a handle or whatever, which also has a small pinion in it. So we have the bearing for that one, like that. And then we have this a handle center thing, yeah, that's the handle. And this pinion and the bearing and the handle center, all these three are shrink fit all together. It's also one piece, finally. And then we have inside there we have a holding washer as again, so it doesn't come out from there. Okay. Well, finally, now it's almost like there. We have one final thing, which is the lever where you crank it, and then a ball on top of it. Let me show you the ball. Well, here you have the ball. It's just a ball. So, yeah. And now, oh well, that's about what we are going to do. Well, there will be multiple. Okay. Let her stay there. There will be multiple episodes for this one, probably more than 5. Yeah, and this time we are going to make the frame, because you need something to build this into. That's, well, yeah. And then we make some of the bearings, the bushings there. those which are attached to the frame, of course. And then there will be also an integral part of the frame is the pinion pin. And finally we will, well, maybe we make the upper shaft, maybe, let's see. But, well, let's start with the, what shall we start with? What's her opinion about this? Maybe we start with the pinion shaft. It's the easiest thing to do. It's a very simple thing, really. Okay, well, so let's go on. Okay, first, before we go on with the pin, I would like to cut the materials, because the weather is now nice outside, it's not raining, it's not dark, sun is shining, etc. So it's a joy to do it now outside, so I will do that first. Well, I'm marking the materials now before cutting them, and well, we need for these we need 2 pieces of 100mm length, and for this one 255. Oh wow. What? Okay. Okay. First, the pinion pin, and this one is, well, it should be 8mm in diameter, 8mm in diameter, and 40.1mm long. And then we have M4 thread in the other end, 10mm deep. Well, yeah. And this is just some 10mm cold rolled steel. after some turning and then filing and finally using some emery, I have now got this quite near what it needs to be. Hopefully you can see it when I measure it here now, like that. That's quite exactly 8, I believe. And if we measure it in between, it's still. And the final here is, well, let's see. Oh, it's still. So 3 points inside 1/100 of a millimeter, 8 millimeters. Okay, now I'm going to drill a 3.3 millimeter hole into there, and it will be, the document says it should be 10 millimeters deep. Well, this is for M4 screw. Well, I make it 15. Well, let's stick to the document. Let's drill. So 10 millimeters deep. That's it then. Let's see if I move this a little bit away. I'm using this tab follower, and then the tab, and then I have this fancy looking tool. Let's move this further. I locked it, so I cannot move it further. There you are. Then I tighten this just a little bit, like that. Oh well, and then, well, this time I will be using Rocco because, well, it just is so that this cutting fluid works better with threading. And you don't need a lot of that, and then I also switch off the lathe. Wait until it really stops. I don't want any accidents here, really. There you go. And now, let's go. This is a spiral flute tap, so it will eject it will lift the chips off from the threads, and it does. Well, as you can imagine, this goes really like very easily. That's the bottom. I don't want to strain it any further than really needed. And then just roll it out from there. Joo. Done. Just taking care of that corner. And then we need to part it. The speed is suitable, but here, okay, let's see. So this needs to be 40.1 millimeters. And now this is 3 millimeters wide, so I give it 41, so it should be 44. And I think we can find it with this speed. We should be able to. Let's see. There we go. So this way it should go. Oh, it's really precise. Take care of the lever first. Now it's 14.84. So 14.84. Let's put this right here, and then I zero my dial here as well. Okay. Then I lock the carriage here. Okay. Now. So we need to remove 74, like that. That was 0.25. That's 0.5 now. Wait. And now we are 0.5. So 74 was it? Well, let's try that. See how near we get. So, it should be there. Well, I would not say it's not too bad. This is like 200ths of a millimeter undersize. So now this pin, well, here it is, the pin. Pin is ready, and well, next step will be to mill the side stands. The ends of this thing, going to use these pieces. Unfortunately, these are 10 millimeters too thick. So I first need to rough out 10 millimeters of the surface. Well, that's waste of material, yes, but this is the only steel I have in suitable dimensions. So now, well, it will be completely, totally, entirely a milling job. So, and the piece looks finally as like this. Let's put this animal away again. It looks like that. There is a big hole for the eccentric, and then we have this smaller hole for downstairs roller. Well, and they are a little bit different. The other one has the hole for that pin. Other than that, they are identical. Okay, well, the milling job that is, and so, well, let's go on with that one. Well, this is quite large roughing end mill, and I will take 8 mm deep cut from this. This is not soft material, it's somewhere in between in hardness. And well, it machines quite well, and now I will, so, yeah, what's there to say? Let's go. Well, I'm running this about 200 RPM, and feed is 17 millimeters per minute. And I'm using cutting oil. now it's time to put some holes through this workpiece. And well, yeah, here is the drawing. And our first hole is that that thing there. It's the dimension will be 8 millimeters. It's for the pin in there. I have positioned the workpiece here. It's dialed in straight. It's well, perpendicular or parallel with the table, however you would tell that. It's also in a suitable place. I also calculated that the biggest holes that come here reach 11 millimeters from the edge, so I have 10 millimeters parallels here, and I can feel here in the back that they are a little bit away. Both of them are. So I should be able to drill the needed hole here. And then I should also be able to drill another hole here and yet another which we will make first. But all those holes I should be able to drill without drilling my parallels or the table. Well, I could probably slow it down a little bit. Now it's 380. Oh yeah, okay. Oh man, you know what? The hole is in the wrong place. I don't know. Man. Well, very nice. Scheisse. Yeah, it's in the wrong place. Very nice 8mm hole, but in the wrong place. Where did I get this 23? Yeah, from that one. Well, the hole. Well, I decided to plug it. It was easy enough to turn a 8mm pin and then glue it inside there. Well, it's now done. And yeah, next hole. Now I triple checked that that is the correct place. And this hole will finally be 20mm. So, and running this, well, about 400 RPM. The feed is what we decided that is good for this 7.5mm drill. Very nice surface, at least. Hopefully it fits in. Yeah, it did. There you are. This Wollhaupter has a very accurate scale, so I know now that it is 66. I'll take it in 2 passes. That. 66. Let's turn this out. Yeah, 66. If I divide this by 2, I get 33. So first 33. 1, 2, 3, and 1, 2, 3. Okay. And then when I take another, it should be all right. I don't want to scratch the surface, which is, by the way, really nice. Well, let's measure it. Well, I could also actually, I can take it to the side. I can always go back to that. Yeah. Yeah, now it should be quite exactly 20. Let's see. No, it's not. Why? This surprises me every time. No. Why? It's oversized. But it could also be a measuring failure. Well, it's oversized. It's 20.30. Well, I know what I made wrong with this hole. Well, lucky me, it's not the Wollhaupter. Nothing wrong with that one. It's all wrong in my head. So, when we were at 19.60, was it 66? So, I thought that, okay, now I need to make it 0.66 larger. Yeah, and I made. And I ended up having exactly the hole what we have here, which is 20.32. Yeah, okay. So, it's accurate, really. But now, a new hole. And yeah, I am tempted to make the other side similar. Yeah. And change the plans. Yeah, okay. So, running this at 400 RPM, feeding 17 millimeters per minute, drilling all the way through. 7.5 millimeters drill. probably, I have made a few mistakes today. None of these were like, let's say, terminal. I could recover from those. The last mistake I made, I read my papers wrong, and this should be 35 millimeters, now it's 39. Well, okay, let it be like that. It's bigger now, but then again I make the eccentric myself. I just need to adjust the drawing. Yeah, that's the good thing about this. You can always adjust the drawing and then claim that, okay, it's as documented. Well, yeah, okay. Anyway, those are really typical, very typical mistakes I made today, really. Okay, I guess my brain works a little bit in a strange manner. So, I think this concludes now this episode, although this piece isn't ready. We need to have holes in here and also threading those. But that's all that is needed. Well, of course, I need to make an identical piece to the other end. Well, not identical. It's missing 2 8mm holes, and especially the one which is in the wrong place. Yeah, okay. But till next episode, bye!